So in this video we're going to do a little more antiderivative practice. Some may involve u sub, some may not. So here's my first one, e to the 1 over x squared dx. So I got division in here. There's no basic rule for this. We can't split an integral up over division. I'm seeing this as a u substitution. What I see is the 1 over x in the exponent and then an x squared in the denominator. In other words, I could rewrite this as e to the 1 over x times 1 over x squared dx. And I see a relationship in there. And that is that the derivative of 1 over x is negative 1 over x squared. So, I'm going to let u equal 1 over x, because that's what tells me what my u is, was the fact that the derivative is in there, and du, the derivative of 1 over x is negative 1 over x squared dx. Now I've almost got that, except I need a negative in there. Well, the way that I do it, I like to say, okay, well, I need a negative. Let's put one in there. But I've changed what I originally have, so I got to fix that or compensate for it, and so I do that by putting a negative outside. I now have my substitution. That is exactly u. Du is exactly this piece here. So what I have is the negative antiderivative of e to the u, because I'm just subbing in my u, and then this whole thing is just du. And we get what was fairly complex looking, is actually probably our easiest antiderivative we have, e to the u, whose antiderivative is e to the u. Now we have a negative out front, so it's negative e to the u plus c, and then we sub back, we have negative e to the 1 over x plus c, and we're done. Let's do another one that also involves u sub. We have 2 e to the x plus 4x all over e to the x plus x squared dx. Now, this is not a real obvious u sub unless you've had some practice with u sub. But what I do see, 2 e to the x plus 4x, that's double the derivative of the bottom, because the bottom, the derivative is e to the x plus 2x, the derivative of the denominator, that is. Which double that is exactly this. So that tells me if I were to use this denominator as u, I could get its du in there because the derivative of it is in there. So I'm going to choose u to be the denominator, which is e to the x plus x squared. Because then my du is e to the x plus 2x dx. Well, I don't quite have that in here, so what I'm going to do is I'm going to factor a 2 out of the numerator. So if I factor 2 out, I'm just going to pull it completely out, then I have e to the x plus 2x all over e to the x plus x squared dx. Now the denominator is exactly my u. So that I already know is going to sub in. So I have 2, and in the denominator I'll have u. The numerator, this part right here, is right here. So that's now exactly my du. So I get du over u. Now we're not always used to looking at this one this way, but this is the same as 2 times the antiderivative of 1 over u du. These are the same. This is a little more familiar looking. This is the antiderivative of this is natural log of the absolute value of u. So this is 2 times the natural log of the absolute value of u plus c, and then we sub back. So 2 natural log, our u in this case was e to the x plus x squared, which is always positive, so we don't need absolute value. It wouldn't make it wrong. We could just use parentheses plus c. So there's a couple involving u substitution.